I want to thank all of you for being my viewers because this month, June 2015, is a month where my YouTube channel had three firsts. It broke the 10,000 views barrier, which makes me very happy. And it's also the first time that all age categories were represented amongst my viewers. And it's also the very first time I recorded female viewers amongst my viewers, which I appreciate a lot. So, thanks again. And, well, now follows the next episode of the Sony 5303E restoration. I decided that I would replace any and all parts that need replacing on the Sony first before I got down to repairing it. And I'm saying this because the owner from whom I bought this little set said that the TV doesn't work. So there must be a problem, but maybe it's, who knows, maybe it's just the fuse that's bad, or a bad contact, or something like that. But before I would start to make a serious attempt at repairing this TV, I thought it wouldn't be a bad idea to replace all the obvious worn parts, which includes, of course, all the electrolytics and maybe a few capacitors or I mean ceramic capacitors, or who knows, maybe even a few resistors. Anyway, like I said in the previous episode, Sony touted this kind of TV, well, and I would say this specific model, as well, let's say revolutionary, in the sense that all the print boards inside the set are all print boards that can be slotted into connectors, big connectors like the one you see here. Yeah, and this is supposed to allow any technician to simply pull out the PCB and to be able to work on it separately, instead of having to unsolder I don't know how many wires and all that to be able to work on it. Not a bad idea, of course, except that especially with those early PCBs like this one, and you can see it's really very ugly. The copper traces weren't very solid and all, and these connectors and these copper traces are a bit infamous for creating a lot of bad contacts. So I wouldn't be astonished that a possible source of the problem with this TV is that there's a lot of copper corrosion going on and bad contacts and all that. Okay, so I thought I would start with the obvious part of the set, which is the top PCB. And if you look closely, the PCB is located into its connector, which you see here, and if you look even closer, you see that the connector is really built like a hinge. You see, it has a pin on this side which is hooked into the metal part of the chassis, and it has an identical pin on this side. So this connector really swivels up normally, and which should allow me to pull out this PCB. Now, as far as I can tell, the PCB is held in place by the connector and also by these two metal placeholders, let's say. So this one and that one over there. So what I need now is a very small Phillips screwdriver to undo these two metal struts. So let me just do that. Hang on. Okay, well, let's have a look. Okay, I have a very small screwdriver, so let's see if I can unscrew the whole thing. These screws are really tiny, so I really have to be careful not to lose any of these, because they would be very hard to replace. Okay. My guess is they are quite loose, that somebody opened it up some time ago to have a look at least at the PCB. And well, like I said last time, I'm sort of a little bit, well, I feel some trepidation, because if the guy or whomever did some work, quote unquote, on the TV, that would be, it could be a small catastrophe. Okay, well, like I said, it's swiveling up a bit. Okay, well, there are still some wires hooked up to it. Okay, so hang on. Now I need to disconnect the print board. Okay, let me have a look. I'm going to mount the camera on the tripod so you can follow what I'm doing. Okay. Well, I think with a bit of luck you will get a first row seat on the action. Close up. Okay, so here we go. I should be able to pull out the print board. It's surprisingly easy. There it goes. Okay, well, okay, now before I start disconnecting anything inside this little TV, I need to make a few pictures. I need to document what I'm doing, because I really don't want to have to look for the right connectors when I'm done and all that. So give me a moment to document a few things, then to pull loose the cabling that is still attached to the print board, and then I'll get back with the next part. Alright, so I disconnected these two wires, and I'll confess right now, right this instance, I couldn't tell you which these wires, what function they perform inside a TV. And I disconnected them from the two connectors you see over there, which are marked as Y and a G or C. It's kind of difficult to read. So in any case, I disconnected them from those two pins over there. And the connectors are a pretty simple triangular clamp which slides over the connector pin, which in my opinion is also, well, not too good a type of contact, because they can oxidate and or slide off, and well, it's really not a very good idea to use this kind of slide-on connectors. They are prone to creating a lot of bad contacts and all that. Anyway, this board is really all that is needed to do all the basic functions a TV needs to create an image. You know, the horizontal sweep, the vertical sweep, the synchronizing, the linearity of the image, you name it. So this board has it all, and it's quite compact. Frankly, there are so many parts crammed onto this board that when I'm going to replace the parts on it, it's going to be, well, it's not going to be very easy or comfortable. Even if I completely disconnected from the TV to work on it, well, you can tell for yourselves that a space on this little PCB is truly at a premium. There are a few transistors, few power transistors you see on the right side, so here and there and there. These little power transistors really look cute. I don't know yet what their function is, but I'll look it up on the schematic. So there are quite a few electrolytics and say TO3 type transistors on this print board. I would say 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, that's about it. About 9 electrolytics. Neither of them are big. And then there's one paper cap here of let me see, I would say 50 nanofarads or 0.05 microfarads, and it's rated at 400 volts DC. This one might cause me a little bit of a headache, because I don't know if I have a 50 nanofarads 400 volts which that will fit in here. So that could cause me a little bit of trouble. Now when I look closely at the print board, I don't think there has been any work done on it. In fact, I'm almost certain no work was done to this print board. This is all factory original. They used even tiny dog bone resistors on this PCB, which is kind of funny. Using dog bone resistors on a 1963 PCB, you know, on a 1963 TV, you'd think that by now they would use regular resistors and not these cute little dog bone resistors. But, well, actually, you know, when I look at the state of the copper traces at the back, I'm a little bit, well, horrified. I mean, it's dirty, it's sloppy, it's full of burnt resin, it's oxidated everywhere. It's hellish, and it's also full of wire bridges, which tells me that the original design of this PCB is probably, or has probably not been walked through the park for the engineer who designed it. And so instead of using double-sided PCB, they used single-sided PCB and bridged wherever they needed to bridge with simple wire, which is the cheap solution, of course, but it's really not a neat solution. So, is this a nightmare? Well, it's a bit early to say whether it is or not. But I can tell from the very close spacing of the parts that it's not going to be easy to replace any part on this PCB. So, I took the necessary pictures. I'm going to disconnect the print board, and then I'll replace the parts on it. Now, before we go that far, there's still one more thing I would like to do, and that is to test the filament of the picture tube, because if the filament of the picture tube is bad, then I think I'm going to put this project on the back burner until I can find a replacement tube. So yeah, well, let's have a look whether the filament of the picture tube still works. Okay, so here is the print board unmounted. So I disconnected all the little connectors on this side. I made plenty of pictures, but I also made a small, well, let's say, I stuck a small piece of tape with the colors written on it, just as a sort of a memory help. But, well, like I said, I took plenty of pictures of everything, so reconnecting the print board should not be a problem. Anyway, so yeah, this should make my life a little bit easier when I work on the print board. But it's like I said, it's not going to be a walk through the park because, well, all the parts are really crammed on there. But it's a challenge. It's something new to try. So I'm curious, and I'm sure so are you. So I disconnected the CRT connector, as you can tell for yourselves. It's a tiny little connector. I pulled it loose and the end of the CRT looks okay. Now, the strange thing is all the wires that go to the CRT are coated with a sort of a sticky white stuff, and I really don't know what it is. It's sticky, it's dirty, and it sticks to my fingers, as you can tell. And all the wires are coated with it, you know, like this red wire here. This is really dirty stuff. Maybe it's that infamous kind of plastic rot that occurs on certain plastic parts. I don't know. But, well, the thing is, I will have to clean it. Anyhow. I also pulled loose the piece of felt which was glued to the connector, the print board connector. Well, for several reasons. First of all, because I will need to clean the connector sooner or later. So that should make my life a little bit easier. And it would also fall back all the time and bother me while I'm working on the TV. So yes, I'll glue it back, no problem there. There is one thing I did not mention a few minutes ago, and which is this part here. Now in here, if I'm not mistaken, are the three rectifier tubes, the 1DK1 diode rectifier tubes. And I'm going to open this, don't worry, because I'm curious myself as to what's inside of this. And anyway, I will have to check whether they still function or not. So yes, sooner or later in one of the next episodes, I will open this little box here. By the way, there's marked U594U on it. I don't know what the number means. It might be a factory number to designate the part, or it might also be a quality control stamp. Don't know. I'll look it up. Maybe I can find something about that. So anyway, I connected the pins 3 and 4 of the CRT to my brand new power supply, which I had failed to show you. I bought myself for a very reasonable price a brand new power supply, where a DC power supply obviously, where I can set the current and the voltage. If I'm not mistaken, it can deliver 5 amps and up to 30 volts DC. And it has a negative and a positive, and it also has a ground, which is not necessarily the same thing as negative. Okay, so anyway, I've got my new power supply hooked up to the filament of the CRT, and in a few seconds I'm going to power it up, and I'm going to set the current and the voltage quite low, and then slowly crank it up, and check whether the filament works or not. Now this is a 140 CB4 picture tube, actually exactly the same kind of picture tube you saw in my Sony TV 520. It's exactly the same 1. So it's a 12-volt filament normally. So that's what I'm going to do now. I'm going to crank up the voltage. I'm going to start fairly low at, say, 2 volts or so, and then slowly turn the voltage up until I see the filament glow. And hopefully that is exactly what I'll see. Let me clean up the tube just a little bit, you know, so that I can see any glow if there is any. So okay, let me see. Well, I'm going to, in a minute, I'm going to grab the camera and show you what's happening, but okay, here we go. So I set my voltage supply, my power supply, to 2 volts. So here we go. Okay. It's drawing 40 milliamps, or well, 30-40 milliamps. So let me see what happens if I push up the voltage to, say, 4 volts. Don't see anything just yet. Okay, nothing. So let's go up to 5 volts. Now it's drawing 40 milliamps, so something is drawing current, but I'm not seeing anything. Okay, hang on, let me switch off the other light in the room. Well, I'm at 5 volts and I still see no filament glow, so let's go up slowly to, say, 6 volts. Ah yes, now I can see a very faint glow down there. Okay, so let's go up to 7 volts. Okay, I'm at 7 volts and it's drawing about 50 milliamps current. Okay, so let's go up another volt. Okay, I'm at 8 volts now, and normally you should be able to see the filament glow, but it's kind of hard to tell. Well, it's very faint actually. So okay, let's see. I go up to 9 volts. Now you should be able to see it. No, I guess yeah, there. Well, I think you just saw it for maybe a second or so, but trust me, the filament is glowing, and which means that this tube is working fine. So let me see if I just can get another shot of it. Yeah, there you are. So let's go up to 10 volts. Normally you should see the filament. Yeah. So yes, this is a good thing. This means that the picture tube most probably will create an image. Okay, I'm at 10 volts and the filament is drawing about 60 milliamps right now. So once it's at full voltage, I think it will glow quite brightly. And yeah, if we're lucky and there are no shorts in the picture tube, we will certainly have an image. Whether it'll be a good image, that's something else.